think so.
They are gorgeous.
Now that we're finally there, we feel a lot better about it than wondering what the surprise will be tomorrow.
And those are synthetic?
Yep.
Really nice. This is an enormous accomplishment from a really large group of people. This is huge.
Welcome back to Creating Synthetic Life, your questions answered. I'm Paula Zahn. We are joined again by genomics pioneer and biologist, Dr. J. Craig Venter, the man toasting the champagne there, the man who led the team creating the world's first synthetic life, Michael Spector, writer for The New Yorker. Joining us once again, Harvard University molecular geneticist and one of the founders of the Human Genome Project, George Church. And joining us now is Lee Silver, professor of molecular biology at Princeton University. That moment was a long time in coming, Dr. Venter, when you were celebrating a great moment of victory. And I think that there are a lot of people in our audience out there tonight and Facebook users that want to know where you're going to go next. And along that line, I have a question from one of those users. There are quite a number of possibilities that this type of research can open up. What will be the focus point, at least in the beginning?
There's two directions we're going to go in. One is now we have the tools to do what we started out 15 years ago, and that's to get down to understanding the minimal instructions necessary for a cell and understanding what all those genes do. On the other side, we want to see how extendable this is. The two species that we used were roughly the same distance we are from mice. So can we go a lot further in the genetic code and the machinery in the cell to read it? Could we use some of what George Church has been doing, starting with the other end of the process with synthetic ribosomes and just putting a few of those in and booting up the genetic code from scratch? There's so many fundamental questions. And then trying to build a synthetic algae to see if we can really get the solution to capture CO2 and maybe start us getting weaned off of oil.
These are some very exciting goals that Dr. Venter is talking about here, yes. Professor Silver. What are some of the challenges that lie ahead as he tries to reach ahead?
Well, there are obviously the scientific challenges that Craig and George can talk about extensively. And I think there's also a societal challenge, and the societal challenge is to get across the idea that this technology can provide enormous benefits for humanity, and that this technology is needed right now. We now have several problems facing us as a world society, including climate change, including replacements for fossil fuels, and developing new medicines. There are many challenges. And biology provides this really powerful tool set to approach all of these. And so things that were just science fiction 15 years ago, most scientists said what happened now couldn't have happened 15 years ago. And I see this very bright future of being able to use the power of biological systems to challenge the problems facing the world.
So it took you 15 years to get to this point.
For a couple of years to sequence the human genome as a side project.
Yeah, we'll allow you that little distraction. Thank you very much for that effort. But when you're talking about potentially creating a new way to fuel cars and aircraft, how many more years out are we talking about?
Now that we've crossed this barrier, the next changes will happen a whole lot faster. This was something, and maybe that champagne toast, we were feeling more relief than celebration that it finally worked, because until it worked, it was only an idea. Now that that idea is proven to be real, my colleagues and myself are much more willing now to put the effort in taking it to these next stages. So we had to cross that barrier.
So now that you've taken these baby steps, let's talk about the incremental changes now we'll see in the future, and how quickly will they come?
Well, so some of the incrementalism will be still coasting on the old methods, but they will be blurred in wonderful ways with our increased productivity due to the synthetic genome. So we have companies that are already making pharmaceuticals that you used to have to get from very trace amounts in plants. You can now make them in yeast and bacteria, like Amyris making artemisinin for malaria. We have companies making propane diol for carpets, companies making fuels already, some of them from algae. But these are just going to get so much better.
Some people have argued there's two futures for humanity. One is to find another planet to move to and pollute, or to alter the human genetic code so we can survive in the polluted mess we're making for ourselves. I think there's a third alternative.
Which
we
is?
can use these tools to try and clean up our planet, change the industries, so that in 30, 40, 50 years and beyond, we have cleaner water, the fish can come back, we won't continue to destroy our environment. We have abilities to try and stop what we're